Okay, skill 7.2, graph the quadratic functions and interpret those graphs. So as you recall, and I'll put this at the top, our basic form for a quadratic graph is y is equal to some number a times x minus h squared plus k. Actually, I'm going to write this as x plus h squared plus k. And then our vertex is negative h comma k. So looking at here, I can see that I have negative 1, so that means my vertex is going to be at 1 comma 0 in this case. And I always want to put that as my middle term, or as my middle part of my table. And I can also just plot 1 comma 0 right there. All right. And so then as I go up, I can go 2, 3, 4, and 0, negative 1, negative 2. And if I plug 2 in to my x here, I would get 2 minus 1, which is 1 squared. And then that's negative, so this is going to be negative 1. And what's nice about quadratics is there's that line of symmetry. So if the number below my vertex is negative 1, then the number above it is also negative 1. I could then do the same thing with 3. I could put 3 here. 3 minus 1 is 2. 2 squared, turn it negative, minus 4, minus 4. And then 4, that's 3 squared, is 9, so that's minus 9, minus 9. And then I plot these points. Those are my negative 1, and then negative 4, negative 4, and then negative 9, and negative 9. All right. And then I would draw it in like this. So my y-coordinate I can see is at negative 1, 0, or sorry, is at 0, negative 1. My x-coordinates, once again, is 1, 0, only have one x value, and that's my vertex. The line of symmetry is x equals 1. The domain is all real numbers. And the range is from negative infinity is less than y is less than or equal to 0. And remember, it's less than or equal to 0 because we do actually include 0 because we do have a point where y equals 0 on the graph. And I'll switch up colors here. Do green. So for this next one, if you remember, I would look here. We flip this sign, so this becomes negative 2, negative 2. That's my vertex. All right, and if I plot negative 2, it's going to be here. Then I would go negative 1, 0, 1, and then negative 3, negative 4, negative 5, like this. All right, the y-intercept coordinate. So what I would do is, once again, like before, I might plug negative 1 here. So that's negative 1 plus 2 is 1. 1 squared is still 1. 1 times 1/2 is just going to be 1/2 minus 2, or negative 1.5. Negative 1.5. All right. And then we do the same thing with, we would say 0. 0 plus 2 is 2 squared is 4 times 1/2 is 2 minus 2. Which is 0. So 0, 0, and negative 4, 0. And then we could plug in 3, or sorry, 1, not 3. 1, which becomes 3 squared is 9. 9 times 1/2 is 4.5. 4.5 minus 2 is 2.5. 1.5. And then we can plot these. So we would say, go negative 2, negative 1.5, and then negative 1, negative 1.5, and then 0, 0, and then negative 4, 0, and then 1, 2.5, and then -5, 2.5. So you get something like this. Now once again, for our y coordinate, just going to be 0, 0. Our x coordinates are going to be 0, 0 and -4, 0. The line of symmetry is x equals -2. Right, and that's our line of symmetry. We could actually even draw in like this. X equals -2. Domain is all real numbers. And then range, in this case, our minimum value is -2, is less than or equal to y, which is less than infinity, which is our maximum value because it goes up.